they've gotten enough like really angry people caught in probably pretty embarrassing like hot mic situations where they did not know they were being streamed and they said something they didn't want other people to hear them say, because that's always what it is, right? It's never like, oh, I misspoke. It's just that they were talking out of pocket. And they did not know they were being recorded. But we are being recorded, and we are streaming live to you across the entirety of Al Gore's internet. I am Phil Nelson, and I am coming to you from beautiful downtown San Francisco, California, on the best coast. Our stalwart host, Dr. Satya Malik, is coming to us from
San Diego, California.
Hello, and everybody. We have an illustrious guest with us this week. Brad Suessmith is joining us from.
I'm actually dialing in from Comanche, Iowa, believe it or not.
Oh, wow, Iowa.
But I'm based in Austin, Texas.
It's a good thing you didn't tell me. I would have canceled the entire episode. Just number one Iowa hater right here.
Oh, really?
I kid. It's not like you're Indiana or something. Jeez. Anyway, folks, if you're watching, wherever you're watching, on YouTube, Twitch, Twitter, we are live on Instagram today. We're also on Zoom and on LinkedIn Live. Wherever you're watching, let us know where you are joining us from. OpenCV is a global community, and it is a big point of pride for us that we have people join these webinars from all around the world. So please let us know, and we'll read out some of your good morning, good evening, etc. wishes here on the show. We see it. Good morning from Guatemala. Hello, Steve from Smart Mansion Inc. He's one of our stalwart viewers. Hello, Madagascar. Hello, Bremen. Let's do a quick vibe check. Yeah, hello Turkey. Hello Calgary, Alberta, Canada, home of the great Heart Wrestling family. Speaking of which, if you're a pro wrestling fan, Vice has a new, yet another pro wrestling documentary out called Who Killed WCW. First episode is out on the YouTube. Very interesting. Hello, Munich, Germany. Hello, Uzbekistan. Hello, Colorado Springs. Good evening from Nigeria. Good evening from India. Good evening from Mexico, Vancouver, Canada, Maryland, Sri Lanka, more India. Yeah, we got Chennai. We got people from all over India joining today. Myanmar. Yes, Bruce, the Calgarian, is that the demonym? In the audience here reminds us, don't forget the Calgary Stampede in July, 10 days of party time. Yes, the Stampede was like a big part of the pro wrestling business out there for a long time. Hello, Michigan. And here come the AI assistants. Does anybody want to guess how many we have this week? Last week we were down one. I think we only had 4 last week. So let's give it a quick count. We got 1, 2, 3, 4, 5, 6, 7. That's a record, folks. We have a new record of AI assistants. That's 7 AI assistants. Hello, Angola. Hello, Peru.
Well, the peak AI would be when people send their AIs for dating. That would.
Yeah, well, that'll happen. That's happening already, probably in San Francisco. I'm glad I have removed myself from the pool. Let's say that. Hello, Honduras, Washington D.C.
So the joke is that, the AIs would go and interact with each other so that you don't have to interact with all the different people who are not the right fit for you. And then only a small number of people would be selected for you. Yeah. And then, then you can go and date them, right?
Yeah. And then the AIs can go have sex and you don't have to do anything. it's just problem solved.
So somebody on Twitter said that in India, we call that arranged marriage.
It's arranged marriage with extra steps.
The parents do all the talking, and then finally you get to meet a few and you get married.
That's very funny. Yeah, no, we just replaced parents with AI. That's what we've done here. I love that. Hello, Juan Pablo on YouTube says he's Argentinian but in Brazil right now. Hello, Montreal.
5 minutes past the hour, we can get started.
Yeah, let's get started. Go ahead and give us the intro, Doc.
Yeah, hello everybody. Welcome to OpenCV Live. Today we have a very special guest from Orbbec. Brad Suessmith is a robotics segment leader at Orbbec and is based out of Austin, Texas. Prior to joining Orbbec, Brad held numerous sales business development, marketing, and engineering positions at top companies like Intel, VMware, ARM, Dell, and Motorola. Welcome, Brad. We are very excited to have you on the show, and we are very eager to see what you have got for us today.
Well, thank you so much, Satya and Phil. I really appreciate the invite, and hopefully I'll keep everybody as entertained as you guys can. Let me
That's great. Yeah,
you
so
want me to jump into the slides?
I just want to introduce Phil to the rest of the audience.
Oh,
They
okay.
all know him, but also with me is Phil Nelson, who is the Director of Content and Creative at OpenCV. He produces this show, and if anything goes wrong, it is his fault.
Yes, that is right, folks. It's me, the co-host with the co-most, the second banana, who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends on OpenCV Live, can call me Phil, and I'm here to remind you of a few things that we do on every single episode of this here show, which you are probably currently watching or listening to. If you're not, you might want to get that checked out. One of the things we do here on OpenCV Live is take questions from you in the audience, which we will attempt to answer directly. Send that via the Zoom Q&A button at the bottom of the screen, or by using the chat system wherever you are watching us. We are currently live on Instagram, YouTube, Zoom, Twitter, LinkedIn, and Twitch. So send those questions in, and we will do our damnedest to answer your questions live here during the show. We've also got a special giveaway to you later in the episode. I will be asking a trivia question, which I make up based on the presentation from our guest, Brad Suessmith. And the first person to answer that question will win the OpenCV course of their choosing. You can see what courses are on offer by going to opencv.org/university. Also, we've got a couple of events coming up here we want to talk about at the top of the show before we get started. I'm going to go ahead and share my screen so I can show you some of these things.
One other thing, Phil, didn't we? I thought we had coupons, discount codes for people who attend.
Yeah, I was waiting for our guest to talk about that one. But yeah, stay tuned. You will get some an exclusive discount, folks. We do our best to give our audience things for free. We value your time. So I'm going to go ahead and share my screen real quick. We're going to talk about a couple of things off the top of the show before we get started with the presentation. Did you know that OpenCV is a nonprofit organization? The Open Source Vision Foundation runs OpenCV, which means we are an open source library with a permissive license that is also a nonprofit, and that means we need your help either financially or by volunteering or donating in other ways. You can help us with direct donations right now by going to opencv.org/support. A lot of you probably work for some pretty big tech companies because the CV industry is penetrated damn near every part of society at this point. And if you work at large companies, say like the FANG companies or various other joints, they may even do donation matching. So check with your boss. If you donate to OpenCV, say $50, $100, even some of them up to $10,000, your company will match that donation and help keep computer vision and AI free and open to everyone with the desire to learn. Also, if your company benefits greatly from OpenCV, consider becoming a member organization. OpenCV has 3 levels to our member organization plan: bronze, silver, and gold. These are for companies at different sizes that can afford to support us in various financial ways. Obviously, larger companies can probably afford to give us a little bit more money, but it is not restricted just to cash. You can also donate developer time to help implement or maintain specific features in the library, or add stuff that is even beneficial to your company. If you build hardware, for example, and you want to give us an engineer to make sure that your hardware is represented well in OpenCV, you can absolutely do that. You can also sponsor OpenCV on GitHub. You can go to github.com/sponsor/OpenCV. We've got 6 wonderful human beings supporting OpenCV on GitHub sponsors right now for just $9 a month. We'll give them their 15 seconds of fame. Thank you, Victor. Thank you, Jesus. Thank you, Blue Jay. Thank you, Amigu Pavel. Thank you, Ross. And thank you, Rudis Labs in Dayton, Ohio. Also, OpenCV has merch. you can buy OpenCV t-shirts. And in fact, we have a 20% off everything promotion right now. I know our clothes and bags and buttons and pins are a little bit more expensive than you might be used to on this store. Because we're a nonprofit, we kind of have to ratchet up the prices so we can actually get some benefit from selling you the swag that we have here. And so this 20% off actually makes a pretty big difference. So go check it out. We've got buttons, pins, shirts, pet bandanas, bags, stickers in a bunch of different languages. We've got the I Love OpenCV shirt designed by me in English, simplified Chinese, and in an Espanol. If yo amo OpenCV, go check that out. Also, coming up very soon, we've got CVPR 2024 in Seattle, Washington. Unfortunately, it sounds like Dr. Satya Malik will not be joining us for CVPR this year, so we're a little bit brokenhearted about that. But we'll try to have fun without him. Doc, do you want to, even though you're not going, do you want to tell the people what's so awesome about CVPR briefly?
Well, CVPR is the biggest computer vision conference in the world. When I used to publish on CVPR, there were about 1,000 people, maybe 2,000 people who used to show up. Now the audience is 10,000, 11,000 people. So it is a very big conference. You will see, you will get to meet top researchers there. You will get to see, cutting edge papers, but there is also an exhibition booth where you get to meet a lot of people from the industry. So it's an amazing event if you want to know what's going on at the cutting edge of computer vision. So I highly recommend you go and check it out.
Yeah, absolutely. I've also heard a rumor that our friends at Intel will be throwing another awesome party at this event. Last year's was absolutely killer. Huge shout out to everybody at the Intel team that put that together. I don't want to put them on blast here, but you all know who you are. Super fun. Also, next week, and so that's Friday, or that's Monday, the 17th of June through Friday, the 21st of June for CVPR. You can still register and get your ass to Seattle. I will be there. Shichi will be there from OpenCV China. Also, probably Gary Bradsky, maybe. I'm not entirely sure. He's sort of like the Sasquatch or the Yeti. He appears and disappears sort of semi-randomly, like a rare Pokemon to try to bring it a little more modern. We've also got another really exciting event coming up here for Open Sauce. Open Sauce is happening here in San Francisco at the Cow Palace, one of the formerly known as the West Coast Mecca of professional wrestling back in the day when big time wrestling was there pretty often. Since then, we've had, a lot of the great local indies like APW, etc. Anywho, we are throwing a party before Open Sauce here in the Soma neighborhood in San Francisco, California, at Studio 45's new space here in Soma. So you can check this out. I will drop the link in the chat. It's going to be a really fun event at a cool new space, sponsored by OpenCV, CrowdSupply, Hackster, Informal, Open Robotics Foundation, and Particle, who I don't know yet, but I'm looking forward to meeting. OpenCV is everywhere. We are on LinkedIn. We are on Instagram now, apparently. I think we might end up having a TikTok soon. I'm kind of scared, but if something's not scary, it's not worth doing. I'm trying out new stuff like the Facebook, inside baseball, the Facebook streaming is basically worthless for us numbers wise. And so I'm giving Instagram a shot here. Some folks are watching this on my Instagram right now, and I appreciate you. Having said that, I think that is everything we have to. Oh, you know what? That's not even true. We're going to go to opencv.org, and we're going to talk about the latest OpenCV release. OpenCV 4.10 just dropped earlier this week, and I wanted to let people know quickly about that. We got to do something about these load times, Satya.
Okay, that is not acceptable.
OpenCV 4.10 is now available. It dropped on June 4th. There's a bunch of additions and changes, including a bunch of new stuff on the OpenCV Model Zoo. You can check out the full changelog on GitHub as per usual. For being a a .x release, there is a ton of changes here. A huge shout out to the team for continuing to crank through this stuff while working on the very important biggest release ever, OpenCV 5, which will be coming later this year. You can follow the progress of OpenCV 5 on our special GitHub project board by seeing what's in progress, what is still to do, and what is done. You can comment on these issues. You can open new issues if you want to help test things, etc., etc. That is it for me for now.
All right. All right. Thank you so much, Phil. Brad, it's your show. Take it from here, starting with a short introduction, and then we're very eager to know what's in the slides.
Okay. Thank you again, Satya and Phil. Let
Thank
me
you.
get my slides up.
So one of the things while Brad is getting his slides up is if you contribute to OpenCV, if you want to volunteer to contribute code to OpenCV, and if you're working for some of these large companies, you can actually, for the hours you have contributed, some of these companies actually donate money to OpenCV. We are figuring out the process. In fact, I found out these things this weekend, and we are trying to figure out how these things work. But it looks like if you're working with some of these large companies like Apple and others, you could work for OpenCV. Let's say you contribute 20 hours in a year to 30 hours, then they pay $1,500, $2,000 to the nonprofit. You can choose, you can tell them that you worked and you will have to present some evidence. And then OpenCV can get benefited not from just your contribution, but also from the cash contribution from your company. All right. Sorry. Brad, go ahead.
No problem. Can you see my slides?
Yeah.
Acceptably? Okay, great. Thank you, everybody. Again, yeah, the title of my presentation is Robotics Perception the Easy Way with Orbbec 3D cameras. And as indicated earlier, I'm a robotics segment leader at Orbbec. I'm actually a recent employee at the company, having joined in January of this year. But prior to Orbbec, I was with Intel for 13 and a half years, and the last 6 of those years were with the Intel RealSense team. So I have quite a bit of experience in the depth camera industry and working with robotics OEMs. And yeah, I think the rest of it was already introduced, so I'll jump into the agenda for the presentation. I have about 25 slides, so I'm going to breeze through it pretty quickly. But I'll start out with an introduction and level setting for people who aren't familiar with depth cameras, what they're useful for, how the technology works, and then jump into some of the products and services that Orbbec offers to address the robotics market. And then I've got a separate section on our recent collaboration activities with NVIDIA. And then I'll wrap it up with just a couple of slides on Orbbec as a company, in case people are interested in learning more.
I've heard about that company, NVIDIA.
Yeah. Yeah, it's a good partner to have. Okay, so first of all, what's a depth camera? So everybody's familiar with cameras. They generate a red, green, blue value for every pixel in the scene. What a depth camera does is simply adds an additional value to every pixel in the scene, indicating the distance to that pixel. Typically, it's a 16-bit value. Now, for a computer, it just needs to look at the data. It doesn't need to visualize that. But for human visualization of the depth image, we use what's called a depth map, and that's indicated by this red, green, blue image on the right side there. So the color selection there is kind of arbitrary, but in this case, we chose to use the color red to indicate pixels that are close to the camera, and then green for pixels that are kind of intermediate distance from the camera, and then the blue is the pixels far away from the camera. So that helps you to visualize the scene in terms of distance information. There's actually 3 major technologies that are used to produce this depth data. I'd say probably the most common one is stereo. Stereo is pretty simple to understand because it works exactly like your eyes do. You have two camera sensors, and depending upon the distance to the object, the disparity shift or the shift in perspective, so to speak, changes. Objects that are close to the camera shift quite a bit in perspective, and objects that are farther away shift a small amount. And so basically, there's a high-speed triangulation calculation that gets performed to calculate that distance. The next method is called structured light, and this is also a triangulation mechanism, but instead of having two sensors, in this case, you have a near-infrared projector typically that emits a coded pattern onto the scene, and then the right camera sensor views that coded image and looks at the distortion of the image to calculate the distance to the pixels again. And then the last one is called time of flight. People usually associate this with LiDARs, where you're sending out a light beam and measuring how long it takes that light to return to the camera. There's two major mechanisms. One's called direct time of flight, where you're actually directly measuring that time of travel. And then the other one is called indirect, where you're looking at the phase shift of the light wave as it returns to the camera. And of course, there's pros and cons to all these technologies, depending upon the lighting conditions, the distance to the subject, motion, power, cost considerations. Different technologies have different strengths and weaknesses.
So one more thing I would like to add in this setup. So these are the most common ones, but occasionally what happens is that in some camera systems, when you have a stereo setup, sometimes the stereo setup doesn't work when you have flat surfaces. So people add structured light, so they would add one projector, infrared projector, just to get some texture. So it is basically two cameras, and the projector just works as a dot projector, so that you can do this easily, right? So sometimes in these cameras which work in many different environments, they just add a projector in addition to the left and right image. So there are two kinds of structured light in that case, right? One is the camera projector system, whereas there is one camera and one projector. And the second one is two cameras and one projector, where the projector is just adding texture to the system, to the environment.
That's correct. Although the one minor difference there, though, is typically the pattern that gets projected is a pseudo-random array of like dots and dashes. It's typically not coded, which allows for multiple stereo cameras to share the same scene without interfering with one another. But
that's right.
But yes, there's a lot of variations of each of these technologies. You'll find everybody's got their own unique way of implementing them.
So, Brad, for people who for these three use cases, could you just briefly tell the audience in which cases these are more appropriate? In which cases would you choose one camera system versus the other?
Yeah, I actually have a table and a backup slide, but in general, stereo is probably the most adaptable to outdoor operating conditions. Most passive stereo designs are capable of operating in full sunlight because there's lots of natural texture outdoors, grass and trees and cars and houses. Whereas typically structured light cameras and time of flight cameras, they operate at a wavelength of 940 nanometers. And at that wavelength, the sun also emits a lot of infrared energy, which tends to drown out the projector or the light source for those. So they tend to struggle outdoors, I would say.
Right.
On the flip side, stereo cameras tend to have poor edge definition because there's always some pixels that the left sensor can see that the right one cannot see.
Right.
And that's an area where time of flight cameras tend to have an advantage because either the photons hit the object and return to the camera, or they continue on past the object. So you get really crisp edges, which I was going to cover a little bit later, but for pick and place applications, that's really helpful.
That's great.
And the structured light cameras are really strong in terms of accuracy. So if you need the best accuracy in terms of, comparing the data the camera's generating to the actual ground truth measurement to that object, structured light's going to give you the best accuracy or precision.
Right.
Where, stereo cameras are really accurate at short distances, but their accuracy degrades kind of exponentially with longer distances.
Right.
So they're not typically good at longer distances. You can compensate for that by increasing the baseline, which is the distance between the two sensors, but then the camera grows physically very, very large, and it's harder to maintain calibration.
Right. Right. It's cool.
Did that address the question?
Yes. Yes.
Okay.
Yeah, and a quick note to folks watching out there at home or at the office or wherever they're watching. We are taking questions from you in the audience, so feel free to use the Q&A button here on Zoom or ask your question in the chat wherever you are watching.
Okay. I'll move on. So you may wonder, well, where do you use this depth camera technology? Actually, they're using a wide variety of market segments, and we've highlighted a few of them here that Orbbec services, but there's many more that aren't listed here. But in this presentation, I'm going to focus on the two on the left, robotic arm applications, and then autonomous mobile robots. These are the two main categories that we use. And I think I'll just move on in the interest of time. So in general, for robotic arm applications, and this is a rough rule of thumb, but there's always exceptions to this. But I'd say in that type of application, people tend to prefer time-of-flight cameras. They do use stereo cameras as well, and sometimes structured light cameras for inspection applications. But some of the advantages I mentioned earlier are really important for robotic arm applications. So the one thing is that the objects are stationary. So time-of-flight cameras do well with stationary objects. They have that edge definition that I talked about, high fidelity edge definition. And time-of-flight cameras, their error value tends to be constant over a distance. So when you're building, say, a large depalletization robot system, often the camera has to be quite a distance from the scene because you have to have space for a large industrial arm to operate underneath it. So they provide good accuracy at those longer distances. And also the benefit of most of these robotic arm use cases is that they operate indoors under controlled lighting conditions. So you don't have to worry about sunlight interference. And then the other thing is, again, because you're mounting the camera often at the top of a cage or even at the ceiling level, the cable runs to the computer are quite lengthy. And our time-of-flight cameras, we have two models here that offer Ethernet interfaces, which enables that long cable run. Now, in the case of autonomous mobile robots, a lot of them do operate well, obviously they move around, so they need a camera that can generate a stable depth map in motion while the robot's in motion. And they tend to operate in very varied lighting conditions. Obviously, like a last mile delivery robot that's delivering a burrito to you for lunch, it's got to traverse the sidewalks out in the full sunshine.
Yeah.
And even indoor robots, they tend to work in warehouses and environments where they were built for humans. So they have skylights, they have windows, and sun comes through those windows, and that can interfere with like a time-of-flight camera or structured light camera. So stereo cameras tend to cope well with that type of environment. And then the other thing about AMRs is quite often the designers prefer to have like a 360-degree field of view around the entire robot, like a bird's eye view. And also, there's usually more than one AMR operated in an environment. So there's a lot of potential for cameras to interfere with each other with an active technology like time-of-flight or structured light. So passive stereo cameras do great in that environment because they can interoperate with each other and not interfere. And then also, cost becomes a bigger factor when you have, 10 cameras on a robot. So stereo cameras tend to be a little less expensive than the other technologies. So they're also a good fit from that standpoint.
What about the power requirements of these two?
Yeah, stereo cameras, passive stereo cameras tend to be lower power as well because they can operate without the projector, and the projector is relatively
Oh, that's
lower power, but that is the major power consumption component in the camera is that projector. Typically, you're allowed to vary the power of the projector from off to, like 360 milliwatts, and that really determines the overall power consumption of the camera.
got it.
Time of flight cameras and structured light cameras, again, because they're active technologies, they're relying on that VCSEL laser to illuminate the scene. They tend to operate at a little higher power levels.
Got it.
Yeah, particularly if you want to go longer distances.
Right. So it actually works out very well because in AMR, we would typically want a low power camera compared to, let's say, a robotic arm, which could be a fixed, it's plugged in.
Yeah, particularly, if you got, I have some customers with 16 cameras on a single robot, and that's, that power adds up pretty quickly with that many cameras. So
Right. And the length of these Ethernet cables, is it basically Ethernet specification, whatever length it allows for? Or
yeah,
there's
these
a
are
lower
these are
limit?
these are gigabit Ethernet interfaces. So, as long as the gigabit Ethernet standard, typically, I think it maxes out like 100 meters,
Okay.
if I recall correctly. But obviously, it depends on your cable quality and things
Right.
like that. But yeah, generally 100 meters. Whereas with USB type USB 3, your cable length for a passive cable design is typically limited to about 3 meters max.
Right.
Beyond that, you need active cables or a hub or some kind of repeater mechanism.
Right.
Yeah.
Cool.
Okay. So in terms of robotic arm use cases for the depth data, the functions that use that information are, say you're picking items from a tote, an unstructured array of items from a tote. That depth data is very helpful in identifying individual objects and segmenting them from the background and other objects within the container to enable the arm to grasp the object individually. And also to identify where on the object the gripper should place its fingers or suction cups to pick up the object reliably without dropping it.
Mm-hmm.
And then also, if you're, say, a palletizing robot and you're trying to place the item that got picked onto a pallet, you need to identify where the available empty spaces are on that pallet. And obviously, the depth data gives you that data because you can see where there's a larger distance to the top surface versus the other areas around it. And then if you have multiple robot arms operating together, depth cameras can allow them to operate more closely together and even work within the same workspace, where the camera will slow down one arm if it's about to interfere with the other or its payload, and operate faster when it's farther away. And likewise with human interoperability, industrial arms are very dangerous, and typically people operate them in cages. But if you have a safety certified camera array, these cameras can actually protect the human from danger from the arm by slowing the arm as the humans approach the arm and stop it completely if they get too close to its working environment.
What if someone has given the robot arm, say, a knife or a handgun?
Then all bets are off.
Fair enough.
Particularly the handgun. Yeah, so for AMRs, the use cases are a little simpler. There's two main functions that depth cameras get used for. One is for mapping. So typically when you install a fleet of AMRs in a warehouse, they have to do a mapping run where they basically explore the warehouse and build up a map that they store in their memory of where everything is, where all the shelving is, where the walls are, all the posts, all the obstacles they could potentially run into, and all of its destination locations and things. So to do that, you have to, generate this map, which has all those obstacles in it. And you also have to be able to identify features in the scene that the computer running the robot can use to extract visual data from to enable its simultaneous location and mapping functionality. So basically, to enable the robot to understand where it is within the warehouse at any given point in time. So that's one part of the functionality. And then the other major functionality is for collision avoidance. So as the robot's moving around, it's going to be working with humans and other robots and forklifts and things. So the robot needs to understand that there's an obstacle in front of it, and then identify what kind of obstacle it is and whether it needs to just slow down, stop, or plan a new path around that obstacle. So that's a super common use case for depth cameras and robot designs, AMRs particularly. Okay. So I'll jump into products and services. I realize we're running short on time already.
No sweat, man. You got time. Keep it going, but it's okay if we go a little bit over. We ain't that worried about it.
Okay. So Orbec's a little unique in that we offer cameras utilizing all three of the major technologies. We have a broad family of stereo cameras, the Gemini family, and then we have our femto products, which are our time of flight offerings, and then Astra is the name of our structured light cameras. Now, in the Gemini family, we've recently launched a couple of new members just last week. The Gemini 336 and 336L. These are essentially equivalent to the 335 and 335L cameras, but they add what's called a near-infrared bandpass filter. So one of the other challenges that stereo cameras face is glare and reflections from shiny surfaces. And that comes up quite often in these warehouses or retail stores where you have polished floors. They can reflect lights, overhead lighting into the camera. And that glare creates what we call a hole in the depth map. Basically, if the camera sensor pixels get saturated with light because the light's too bright, they can't generate depth data for that part of the scene. So you get a hole in the depth map. So instead of in that picture I showed earlier, instead of a red, green, or blue color, you're just going to get black. You're going to get nothing, no data. So what this filter does is it filters out the visible light spectrum, and it only allows the near infrared light spectrum to pass through. Essentially, in indoor applications, generally it's essentially forcing the camera to operate solely on its projector, which solves this reflection problem. And then outdoors, again, because in the daytime, at least, the sun emits a lot of infrared energy, it'll see the full texture in the scene, the natural texture outdoors, because the sun is illuminating the scene for it.
It's difficult to put out more infrared light than the sun.
Yes.
Science struggles against the sun yet again.
Yeah.
This is a hardware filter, right? It cannot be switched on and off. It's either you get it with or without it, right?
Correct. It's literally film that gets applied to the cover glass of the camera. You can see, if you look closely, like on the left side, you can see the left and right depth sensors on the 335. Right. And on this camera, you cannot see them because the light's not passing through the filter.
Got it.
And I kind of failed to mention, these are USB Type-C connected cameras, and we have two variants. One is what we call a short baseline camera, the 335, and then the 335L is a longer baseline camera. Basically, the 335 is accurate out to about 3 to 4 meters. The 335L essentially doubles that range. So, 6-7 meters type of operating distance. Now, you might think, well, why would I want to buy the short camera if I can just buy the long one and see everything far away? Well, there's a trade-off. Stereo cameras have a limitation in terms of the minimum distance that it can see an object. And the farther apart those sensors are, the longer that minimum distance is as well. So there's kind of a trade-off. And a lot of times companies will mix and match these cameras on a robot. Say like a last mile delivery robot that has to travel at relatively high speeds. they might use a 335L on the front of the robot because they need to see fairly far ahead to slow down or stop for obstacles, and then use a 335 around the sides or the rear because they don't need to see as far in those directions because the robot's generally traveling forward at higher speeds.
Right.
So that's something else to note.
Yeah, but also wouldn't
Especially if they have a knife.
the granularity of the depth be different in the two cases? Like when the baseline is small, you would get you have that much the number of bits you have can be dedicated to let's say from 0.26 meters to 3 meters, and in the other case those things are dedicated to a larger distance, or that's not an issue.
Correct. Yeah, you can actually change the settings in the camera for the minimum incremental distance for each step in the depth data.
Okay.
And yeah, the 335L, for example, would be as accurate at 0.5 meters as the 335 is at 0.26 meters. That minimum distance is always like the optimal operating point for the camera. That's where it's going to be at its most accurate operating distance.
What does the 335, that number, stand for?
It's a little bit arbitrary. We're calling this the Gemini 330 series. The 5 on the end of the number indicates that it's a camera as opposed to a module or the guts of the camera. That's something that's another product offering we're going to make. That'll be like 330 would be the module inside the Gemini 335. And then the L indicates that it's a long baseline version.
Got it.
We do have a
is just the
plan.
product series.
Yeah, we do have a plan for, the other digits. But yeah, actually, I forgot to mention, the first 3 indicates it's our 3rd generation.
There's that Mike Tyson quote. Everybody has a plan until they get punched in the face.
Yeah. Yeah. Yeah, no, we actually thought through this. Yeah, the first 3 indicates it's our 3rd generation depth ASIC. So these are using our latest and greatest MX6800 ASIC, which implements both passive and active stereo technology. Our previous ASICs were active stereo only, first 2 generations.
So in the depth camera industry, are there? I'm actually surprised, and correct me if I'm wrong. There are no standards in terms of, okay, you would think that because the field is maturing, some of the cameras would be replaceable, by other cameras or other manufacturers also, so that the specifications remain the same, but you swap out the manufacturer if you don't like it. But there are no standards, right? I mean, every camera manufacturer would have their own baseline and field of view and those things, right?
Yeah, in general, everybody implements, depth camera technology in their own way. There is an effort underway at NIST to create some kind of standard metrics for measuring the performance of depth cameras. But yeah, I mean, apart from the USB or Ethernet interface, the rest of the camera and the SDKs are not cross compatible. They tend to be tied to a specific manufacturer.
Right. Yeah, an open standard for this would really help. I don't know whether the companies, it's good for the companies, but it's definitely good for the end users.
Right. Yeah, maybe, as the industry matures, this is still a very, nascent industry. It's a very rapidly growing and changing market. So I'm sure over time things will consolidate and there'll be more, standardization, so to speak, but it's pretty early for that.
Yeah, I mean, if you go back just a few years, like 5 years, basically there was just RealSense selling, cameras at relative consumer prices like this that did depth information and had built-in, filters and things like that. And now we've got Orbbec, there's so many, there's Tangram, another OpenCV member organization, has their depth sensor, and these are finally now hobbyist prices. They're not like $1,500 a piece on the low end as they were before, and so it's a really exciting time for the depth hardware field. I find.
Actually, even before that, Azure Connect was came into the market, as
Sure,
the
the
product.
Connect.
Yeah.
Yeah.
So
Shout out to my buddies Nicholas and Nicholas from France that created the software package Scanect, which used the Microsoft Connect from Xbox to do 3D scans like 12 years ago. Super awesome
nice.
project.
Actually, that's a great segue into our time of flight family, because we are one of the exclusive licensees of the Azure Connect technology. Since Microsoft has, exited the market, they transferred their IP to us. So our Femto family there is based on the Azure Connect DK hardware design. So for people who are using, the Microsoft Connect camera today, they can very quickly and easily migrate to the Femto Bolt. Essentially, that's a, kind of a plug-in replacement product for the Microsoft camera. And then we created a couple of enhancements to that basic technology. The Femto Mega adds a Jetson Nano SoC to do the depth processing inside the camera. And then it also adds that power over Ethernet interface as well. And then Femto Mega I, which you can tell by the picture, it's an industrial ruggedized version of the Femto Mega. So it's IP65 rated, and it's got M12 connectors for the Ethernet and power and data and synchronization signals. And we also provide a wrapper that will convert your Microsoft SDK code to Orbbec SDK code. So you don't even have to rewrite your API calls.
And all of these, I don't know whether all, but many of these cameras directly work with OpenCV. So you can plug it in, and OpenCV will be able to read the frames, including the depth map, directly from the camera.
Right. Yep. Exactly. Okay. And then, yeah, in the structured light family, we have two products currently. Astro 2 is our latest and greatest state-of-the-art structured light camera, very accurate, even at longer distances, up to 8 meters, and very high resolution. I think it goes to 1600 by 1200 depth resolution. Astro Mini Pro is a very low cost, very small product. It's like the size of a AA battery, and it's very inexpensive, but it's limited to VGA resolution and relatively shorter distances. So it's more for cost sensitive applications.
So in the stereo vision cameras, I don't see a sync signal. Does it have sync or?
Yes, actually, that's a good point. We actually do have sync interfaces on all the stereo cameras and the Femto Mega cameras, and we've actually standardized that interface such that you can, buy an off-the-shelf cables, and we've got a sync hub, a couple of different sync hubs that use RJ45 connectors to connect the cameras in a standardized manner. So instead of having to design your own cables and
That's nice.
and soldering connectors on and
Right.
doing that work yourself, you can actually just buy it from us, and it's very inexpensive. But yeah, the location of the sync connector is not shown in this photo, but it's on the end of the camera. USB is on one end of the 335, and then the sync connector is on the other. And then in the Femtos, it's on the back of the camera.
Right. Yeah, that's a really good thing, because I've worked with in one of the consulting projects where we the client had asked us for, okay, this camera should synchronize with something else, and I had not imagined how much work it was just for that feature, because it was almost like a side note in the contract. And we said, yeah, we'll do it, right? And then you go and read the documentation. It was such a pain.
It's
But
a whole project of its own.
Yes.
Yeah. So having everything in a standardized way, and you taking care of all that really helps.
Yeah, definitely. Particularly there's a lot of EMI, EMC interference problems you get when you try to run these sync cables around a robot. And
Exactly.
yeah, by using twisted pair cabling, you eliminate that shielded twisted pair. So yeah, that's a nice enhancement. Okay, we should probably move on. So just to cover our software offering real quickly, we do have an SDK that's freely available, on GitHub, and we have a single SDK that supports all of our cameras, regardless of technology. So you don't have to relearn it or, work with a new SDK if you change technologies. And we're cross OS support. Most robots use Ubuntu OS, but if you're using Android or Windows or some other OS, we support that as well. And then we've got wrappers for both Robot Operating System 1 and Robot Operating System 2 support, and then Unity, Python program environments as well. And then the Microsoft, this is the wrapper that I mentioned that converts the Azure Connect code to Orbbec SDK code. And then just a screenshot of our viewer. This is, the application you use when you're evaluating cameras and, trying to figure out if it meets your requirements and doing some development. This allows you, again, to visualize the data that the camera generates and control the camera and configure it properly. You get a, depth map, you get depth to RGB mapping. You get all of our cameras include an RGB sensor, so you do get a color video stream as well as the depth data. And then most of our cameras include an IMU as well, so you get the inertial measurement, the accelerometer, and gyroscope data. And then a side note, Orbbec also offers ODM and CM services. So if you're a small, robotics startup and you don't have all the resources or knowledge to design the complete robot, we can assist you with, particularly the vision system design. We have a lot of expertise in computer vision, so we are able to offer assistance in that aspect of the robot development. And then we also have contract manufacturing services, so we can build the entire robot for you and manage the supply chain and everything associated with building a product.
That's great.
So I want to quickly touch on a relationship with NVIDIA. We are an official NVIDIA Partner Network member. And I mention this because, NVIDIA is kind of the dominant CPU architecture now for robotics. We do support, of course, Intel and AMD CPUs, x86 CPUs architectures as well. And we've got customers that use, Qualcomm Snapdragons and NXP i.MX8 processors, and any processor can be supported, but NVIDIA is kind of the 800-pound gorilla in the robotics space, so that's why we're talking about them. I mentioned that we integrate the Jetson Nano into our Femto family, and then we do offer USD models for integration into Isaac Sim and Omniverse. So if you want to simulate your robot's operation within a warehouse environment or some other environment, you can integrate our model into your simulation and do the testing that way virtually before you actually build the robot or deploy it. And then last month we released a video, which I'll show shortly after this, illustrating our integration with NVIDIA's Isaac ROS VSLAM and NVBlocks algorithm. So NVBlocks is their name for their scene reconstruction algorithms. And I'll exit this real quickly and show you the video so I can go full screen here. Hang on, I'll restart it.
Looks and sounds good. Man, this music sounds like the beginning of a John Carpenter movie.
Yeah. But as you see the robots traversing around our, this is our kind of showroom at our headquarters building in Shenzhen. And it's building a map as it traverses the lobby area there, or the showroom area. And then, the colors are illustrating the distance from the robot.
Yeah, somebody's just wearing out a Yamaha DX7 on this music. I love it.
Earl Faltermeyer would be proud. Yeah, so this is showing the robot's trajectory around the environment. So this is the localization aspect of it. And all those little dots are features in the environment that it detected with the camera. Okay.
Very slick.
Yeah. Let me see. I don't have much left. Okay. At GTC, NVIDIA announced their Perceptor architecture, which is basically a full stack AMR reference software stack. And when they announced it initially, it utilized a stereo camera, but it's a camera that did not include a depth processing ASIC inside the camera. So it relied on compute blocks within the Jetson. In this case, they used AGX Orin. It used compute cycles within the GPU of the Orin SoC, which works just fine, but that does consume power, and it does require a relatively high performance SoC to perform that function, which I kind of called out in this red block here. I took the NVIDIA block diagram and highlighted that in the red box. So that processing is where they're doing essentially the stereo processing within software, a software algorithm. So what Orbeck's done recently is we've worked closely with NVIDIA to replace that ASIC-less stereo camera with our Gemini 335 and 335L cameras, which incorporate that depth processing ASIC, and thereby we offload the GPU from having to do that processing itself. So essentially that software function in the previous slide becomes just a pass-through function. So you're freeing up the GPU to perform inferencing and other tasks that are important to the robots application. And then just real quickly on Orbbec, this is the last couple of slides. A lot of people aren't aware of Orbbec in the US. The company's been, pretty focused in Asia, but it is a significantly sized company. It's been around since 2013. We've shipped a lot of cameras, over 7 million units, to a wide variety of customers. We have a significant employee base because we do have our own manufacturing facilities, and a lot of really smart people with advanced degrees. We are a publicly traded company on the Shanghai Stock Exchange. We went public in 2022. And we have global sales and support around the world. I included a couple pictures here of our North American headquarters are in Detroit, technically Troy, Michigan, just 30 minutes north of Detroit. And then our global headquarters is in Shenzhen. And some of the advantages that Orbbec offers, again, we are a vertically integrated company. So we do our own design of everything from the ASIC to the optics to the electrical design and the industrial design, mechanical design, and then we build the entire camera. Some of these other things I've already mentioned. We're completely focused on computer vision. We don't have any other business, so this is all we do. There are some stereo camera solutions out there that rely on software, like the one I mentioned in the NVIDIA reference design that they launched at GTC. But yeah, we're one of the few companies that has the capability of designing our own ASICs to offload that compute function from the host computer. And this is just a couple of snapshots of our manufacturing facility. We have, various levels of clean rooms for various functions in the manufacturing flow of the camera. And then we also, build robots and through that contract manufacturing business as well. And we have test environments for that. And we have capacity to build, quite a few cameras per year. And so this is my last slide. Just to summarize, Orbbec is very committed to making your robot development easier, through our wide variety of high quality cameras, plug and play connectivity through USB and Ethernet, very easy to get started. With our Orbbec viewer is, anybody, you can plug in the camera and have the viewer running, and you can be generating depth maps literally in just a couple minutes. Very simple and easy to use. Again, we support, ROS1 and ROS2 drivers. We have great integration with NVIDIA's Jetson ecosystem, the design and manufacturing services I just mentioned on the previous slide, and then local sales and technical support. I included our URL here if you want to get more information, and feel free to reach out to me directly as well if you have any follow-up questions. And that's the end of my pitch. Thank you.
Awesome.
Thanks, Brad.
Thank you, Brad. Yeah, we'll just leave that up there for a second so folks can grab that and get a hold of you. And then we will do our trivia question and giveaway. Also, I hear a little bird told me, and Satya mentioned it at the top of the show, attendees of this webinar will receive an exclusive discount code for Orbbec cameras. So watch your emails, all you wonderful attendees out there here on Zoom.
And if you did attend using some other medium, we do not have your email address, but you can email us at, email Phil.
Newsletter. Newsletter at opencv.org or phil@opencv.org, my very public email address. Brad, you can go ahead and take down your screen share if you don't mind. All right. So if you are joining us for the first time or you just need a little reminder, one of the things we do here on OpenCV Live is give away something to you in the audience. I have created a trivia question, which I will be asking momentarily to the Zoom audience. If you're not on Zoom, you can get there really quickly by going to opencv.live. That's opencv.live. The first person to answer that question will win the OpenCV course of their choosing from the OpenCV University catalog. Go to opencv.org/university to see what courses are on offer. And even if you don't win, invest in yourself, upskill, learn something to make you more money at your job or start a new job. Many people that have taken OpenCV courses in the past have gone on to start their own companies, start new careers, or get paid better at their current job, or even just do it better. So get ready to answer. Again, the first person to answer in the Zoom chat. And if you have won recently, do not answer and give others a chance to win. By recently, I mean within the last 2 months. Talking to you, Partha. A resident trivia shark. So we talked a bunch about Orbbec cameras here. In fact, I've actually got one of the models right here. We'll do a little unboxing video maybe later today. A developer kit. These are the 330 series. What were the 2 full model numbers in the 330 series that we talked about here during the show? What were those 2 models? Oh, you're close. There we go. All right. It looks like Julian Vigil was the answer here. 335 and 336 were the answers we were looking for there. Please, congratulations, Julian, and please send one email to phil@opencv.org with the course that you would like. You can go check out the courses at opencv.org/university. Congratulations, Julian. The answer we were looking for was 335, 336. Also, a legendary guitar model from Gretsch, I think.
Only you can come up with that.
Maybe Epiphone, I think. Yeah, the ES335 is a pretty famous guitar. We've got a metric ton of questions here today. Do you have a few minutes, Brad? Here we're a little bit over, but I think we should answer a couple of questions because there are a ton. Those of you that ask questions, if we don't get to yours, again, please just send an email to newsletter@opencv.org, and we will do our best to answer your question off the show here. let's see. Well, I'm just looking at the Zoom questions here. Tiana would like to know what are the frame rates? What frame rates and resolutions are possible for the 330 series, Brad?
The peak depth resolution is 1280 by 800 at 60 frames per second. It's
Pretty large.
actually, to correct actually, I think we're limited to 30 frames per second at peak resolution, but at 800 by 480, we can do 60 frames per second. That's the peak frame rate. Basically, the depth ASIC can process a certain number of pixels per second. Any combination of frame rate resolution up to that limit, it can support.
Excellent. Another question from Bill Blair. Are you familiar with anyone using Orbbec cameras in a sort of DIY motion capture setup?
Motion capture. Not directly, but it's certainly an application that could be done with a depth camera. Generally, people use proximity sensors for that because it's a lower cost solution. But if you needed, precise distance information and the full detail of the object or person that's walking by the sensor, then depth camera could be appropriate.
Excellent. Yeah, we've got a few questions over. I'm going to switch over. I'll do one or two from YouTube, which had quite a few as well. So another question is what? So folks have been asking about you actually. You're primarily on kind of the sales and informational side. Do you have any history of working on sort of personal projects with any of these devices or cameras from your past?
Believe it or not, most of my background in the industry was in microprocessors. So until I joined the RealSense team 6 years ago, I didn't have any camera experience directly. To be honest, I'm not a real hobbyist, so I use the cameras to do demonstrations for customers and at trade shows and events like that. But I haven't built my own robot with it, so to speak. But I should mention Orbbec does have some education robots that we offer through our store on our website that you could use to get started as well quickly.
Yeah,
But we could tell that you are technical when you played in the VLC player.
That's right. That's right. The real ones know. Shout out to VLC for saving us from Windows Media Player all those years ago. I was there 1,000 years ago. Brad, where can folks find you online aside from? So we got your email there. You're on LinkedIn, probably.
Yeah, I'm on
there.
I'm on LinkedIn. I'm on Facebook too, although I'm pretty non-active on Facebook. But yeah, LinkedIn's a good place to connect with me. I have a lot of connections, so if I can help you reach somebody else in the industry if need be. But
excellent.
Feel free to email me directly as well or give me a call. I'm happy to chat with anybody.
Excellent. And we've got one more here about folks know recently OpenCV's support for depth cameras has gotten better and will get even better with OpenCV 5. They're asking about what kind of data comes out of there. And Satya, this one's more for you. Someone in the Zoom chat here wants to know if they can get Cartesian coordinates for individual pixels in ROS using OpenCV. I don't know the answer to that one.
I don't know, but we can actually send the link to OpenCV, Orbbec camera being used with OpenCV. We have a blog post about it. I think that will have all the information in.
Yeah, I'll snag that and share it before we go off the air here. Our next episode, next week, we will have one of our friends from Voxel 51 will be joining us. That should be a fun episode. Stay tuned for that. I'm trying to think of any kind of last minute, end of the episode chat. Oh yeah, we've got a couple of events we're gonna share here. I literally just got an email about this during the show. So I think we may technically be breaking news here. There is. Let me go ahead and share this window now. I was talking with our friends at Intel. For those of you who are going to CVPR, there is a Intel AI Summit Monday, June 17th. So if you're coming in on Sunday or Monday into Seattle, you can go check out this event. I will share this link in the chat as well. Shout out to Kaushik and all the organizers here. It should be a heck of an event. There's also the CVPR networking meetup by Intel. That's on the 20th. I should be at both of these events. I may not make the first one depending on my flight and situation and stuff. But I believe Shichi Yu from OpenCV China will be at this one at least. But I will definitely be at the event on the 20th. I'll drop these links into the chat. Speaking of, and I'll just take a quick look at this. This is one of those robots that Brad was talking about over on the Orbbec store. It's pretty cool looking robot. Also, I'm doing my own show, Phil's show on Tuesday nights. Check out Phil's show on Twitch, twitch.tv/extrafuture. That's about it for me. Any final thoughts, Brad?
No, I just want to say my appreciation for everyone staying on. I know we ran a little over, and I had quite a few slides, so appreciate everybody's attention. And the questions were great. So.
Yeah, thanks for sticking with us, and thanks to you out there watching for sticking with us. Doc, why don't you take us home?
Yeah, thank you so much, Brad. It was very educational, very nice presentation. I also want to thank Orbbec for being an OpenCV Silver member. I mean, it is like because of companies like Orbbec that we are able to sustain the open source and free OpenCV library. So thank you so much. And thank you. I really want to thank the audience. And as always, thank you, Phil, for organizing this.
Yeah, thanks, everybody. Oh, man, I almost forgot. I have a present for all of you that stuck till the end here. We got one. I finally got one. Somebody heeded my call. And
so this is not your dog, right?
No, this is not my dog, nor is it my girlfriend's dog. This is Kaushik's dog, Bernie. Bernie, you look great in the OpenCV bandana. I expect to have my inbox flooded with photos of your pets wearing these bandanas by next week. You have an assignment. Do not let me down, audience. But in the meantime, take care of yourselves out there and take care of somebody else if you can. Tell your loved ones you love them while you have the chance. Have a great day wherever you may be. We'll see you next week.
Thank you. Bye.
Thanks a lot. Bye-bye.